Hey grade 10s, welcome to your very first unit of Math 10C. Our first unit is called Number Skills, right here. So if you're keeping dividers, you can call the first unit this name. So what we're going to be talking about in this unit is a variety of different concepts dealing with number. So we're going to start talking about some ones that you've seen in previous grades, like prime numbers and composite numbers, prime factorization, listing factors. We're going to move into square roots and cube roots and talk about some things. And then in the second half of the unit, we're going to talk about radicals, which you haven't seen before, and then go much deeper into exponent laws. So you start exponent laws in grade 9, and we're going to continue that process in grade 10. So let's start with something basic today, just as we get going into our unit. So the first thing I'd like to introduce you to is the idea of prime numbers, so prime versus composite. Now, you don't get a definitions test in math, but what you will see is these words will appear in the questions that you get, and so if you don't know what they mean, that will often tell you or give you difficulties when solving that question. So a prime number is a number that has only two factors. So again, sometimes in math, when they define something, they'll define it using another word that you don't know either. So factors are numbers that divide into another number. So for example, the factors of 3 are 1 and 3. Those are the only two numbers that divide into 3. The factors of 11 are 1 and 11. So what a prime number is, so prime numbers have only two factors, the number themselves and the number 1, because those are the only two numbers that divide into them evenly. All other numbers are composite numbers. So composite numbers are numbers with more than two factors. So for example, if we take the number 12, 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. So because all of these numbers divide into 12 without leaving any remainder, we call that number a composite number. So here's a chart summarizing all of our prime and composite numbers. So everything in blue is a prime number. Everything in green is a composite number. Now you'll notice that there's way more green numbers than blue numbers. It's about 3 to 1 actually. So for every 3 composite numbers, there's 1 prime number. You'll also notice that the number 1 is black and all the others are blue or green. 1 and 0 are neither prime nor composite. Remember, the definition for prime is it has to have two numbers that go into it. Well, 1 is only divisible by 1, so 1 only has one factor. In order for it to be prime, it has to have two factors. 0 is another such case. Okay. Now, if you Google search prime and composite numbers, sometimes 0 and 1 are listed as prime, sometimes they're listed as composite. Can't always believe everything you see online. So for the purposes of Alberta education, 0 and 1 are neither prime nor composite, but everything after that is going to be prime or composite. The other thing special to note here, 2 is the only even prime number. Every number after that is going to be an odd number. Okay? Okay, so next thing I want to talk to you about is prime factorization. Now you've seen prime factorization for a couple of years. It's the process of writing a number as the product or times of all of its prime number factors. In earlier grades, you did this by creating what's called a factor tree. I'm going to show you another way how to do prime factorization called stacking. So the example I've got here is 48. Prime factorize 48. So the way a factor tree works is you just have to think of two numbers that multiply to give 48. It could be 6 and 8, which is what I've used here. And then since 6 and 8 are not prime numbers, we break them down. So 6 breaks down into 2 times 3, and 8 breaks down into 2 times 4. Now what my habit is I like to circle the numbers that when I find a prime number, so 2 and 3 are both prime, then I circle them so they stick out. 4 was not prime, so then I break it down into 2 times 2. So then once I've got everything broken down, I've got 2 times 3 times 2 times 2 times 2. Usually we group them together, so I end up with 4 2s and 1 3. So 4 2s and 1 3. Now let's just say for argument's sake for 48, you went with 4 times 12. So 4, you could break it down into 2 times 2. 12, you could break it down into 2 times 6. And 6, you would break it down to 2 times 3. Now notice, you've still got 2, whoops, let's just get that out of here. You've got 2, 2, 2, 2. So you got the 4 2s and the 1 3, exactly like what I got right here. So it doesn't matter what order you do the numbers in, as long as you break everything down by multiplying. Now the other way to do this concept is to do something called stacking. Now stacking is the way that I like. I will tell you this, sometimes in math I can show you more than one way to do things. If you don't like that other way, if you want to stick with the way you've always done it, go right ahead, but I'm all about giving you choice. So I'm just going to write it bigger over here just so you can see what I'm doing. So what we want to do is we want to write an upside down divide sign. And we want to divide 48 by a number. But here's the catch. You can only divide by prime numbers. So I know 4 goes into 48, I know 8 goes into 48, I know 6 goes into 48, but I'm not allowed to use any of those numbers because they're not prime. I can only write out prime numbers. And the reason why we can only write out prime numbers is because this is called prime factorization. So if you're not sure what prime numbers work, remember the first few prime numbers are 2, 3, 5, 7. So 48 is an even number. What is an even number that's prime that always divides into 48? 2. So I go 2 divided into 48 is 24. Now if you don't know that off the top of your head, you're welcome to use your calculator. And now I put a box around that and I start again. Again, 24 is even, so I'm guaranteed 2 is a prime number that will divide in. 12 is an even number, so 2 divides in. 6 is an even number, so 2 divides in. Now I know I'm done my stack once down here I end up with a prime number. So now what you'll see here, let me just see if I can find my highlighter button, just give me a second here. Nope, that's not it. So once I see here, whoops, I've got 2, why isn't my pen working? Let's try the green one, see if that works. Okay, it's not going to work for me here. Okay, so we'll just stick with this. Okay, so we've got 2 times 2 times 2 times 2 times 3. See how it kind of forms in a straight line there? So I've got 4 2's and I've got a 3. Okay, so I quite like stacking. My main thing against factor trees is quite often kids lose the numbers. They lose those prime numbers somewhere in their tree. But again, it's pure preference. So here's another example that I did was 75. So I know that 5, so this is the factor tree. So 5 times 15 is 75. I could have also gone 75 is 25 times 3. 3 is prime, so I would have stopped with that. And then 25 is 5 times 5. So now I've got 5, 5, 3, which is right here, 5, 5, 3. If I were to do a stack, I did 75. I divided it by 5 because it ends in 5, so I know 5 works, and I also 5 is prime. So it goes in 75 divided by 5 is 15. I know 5 goes into 15 3 times, and I know 3 is prime. So 5 times 5 times 3, so there's my answer. So what I would like you guys to do, I would like you to take a few minutes, and I would like you to try these 3 questions right here. I would like you to try 144, 180, and 135. So at this point I'd like you to pause the video and then try those 3 questions and then hit play once you think you've got it. I'm going to go ahead and solve them right now. Okay, so I like to do stacking, so I'm going to stick with stacking here. So 2 goes into 144 72 times. 2 goes in 36 times. 2 goes in 18 times. 2 goes in 9 times. And 3 goes in 3 times. So I'm left with 4 2's and 2 3's. Okay, so for 180, this time I'm going to divide by 5 because it ends in 0. So 180 divided by 5, I don't know that one off the top of my head, so I'm going to use my calculator. So that is 36. Now again, I can't divide 36 by 6 because 6 is not prime, so I'm going to divide it by 3. And then 3 goes in 4 times, and then 2 goes in 2. So I'm left with 2 2's, 2 3's, and a 5. For 135, I'm going to divide that by 5. Again, I'm going to use my calculator to help me. I get out 27. 3 goes into 27 9 times, and 3 goes in 3 times. So I'm left with 3 cubed times 5. There's my answer. So again, if you did the factor tree way and you got out the exact same answers as me, that is just great. Okay, so prime factorization. Now we're actually going to use prime factorization in about 3 more lessons in this unit. So prime factorization is actually going to take on a really big role for us. Okay, the next thing I want to talk to you about is factors. So we already talked about this with prime numbers. Factors are numbers that divide into other numbers evenly without leaving a remainder. So for example, if I asked you for the factors of 36, so the factors of 36 are 1 and 36, 2 and 18, because 2 times 18 is 36, 3 and 12, 4 and 9, 6 and 6. Now I'm just going to write this up here. I'm just going to scroll my page up a little bit. Some of you may have seen this question done like this in junior high. It's called the rainbow method. So you'd start with 1 and 36 on the ends, and then you'd work your way in. So then you'd go 2 times 18, and then 3 times 12, and then 4 times 9, 5 doesn't go into 36, and then 6 times 6 is 36. And you don't have to write out both 6's. So if you saw the rainbow method or the smile method, that's essentially what you're doing there, is listing the factors. Now there's a couple problems with that method. Number one, you have no idea how much space to give between the 1 and the 36. If you have a whole bunch of factors here, sometimes you run out of space and you end up having to kind of go down your page, which is annoying. Sometimes if you have too few factors, you end up with a whole bunch of empty space in the middle, so then it just becomes a waste of space. And some of you really, really, really like your neat looking notes. So I'm going to propose a different way of doing the question. I'm just going to try and erase some work here. So what I propose with this is that we're just going to count. So the 1 divides into everything. So 1 will always be our first factor. So I'm just going to jump down to this right here, number 24. So list the factors of 24. So that is our question. Okay, so what I do with mine is I always start with the number 1. And I go 1 times 24 is 24. So 1 and 24 are both factors of 24. And then what I do is I go down my page and I count as I go. So the next number after 1 is 2. And I ask myself, does 2 divide into 24? Yes, it does. 2 goes into 24 12 times. So I go 2 and 12 are both factors of 24. And now I keep counting. Does 3 go into 24? Yep. 3 times 8 is 24. So 3 and 8 are both factors of 24. Does 4 go into 24? Yep. 4 times 6 is 24. So 4 and 6 are both factors of 24. Does 5 go into 24? No. Next number after 5 is 6. But notice I've already got 6 written in the second column. As soon as you jump from going down one column, as soon as you do that wraparound, you know you have completed your list. Okay, so let's try 216. So 1 goes into 216 times. Now since 216 is even, I'm going to write out 2. Now if you're not sure what 2 times what is, 216. Just go on your calculator, 216 divided by 2, and you'll get out 108. So 2 and 108 are both factors of 16. Now I'm going to try 3. So 3 times 72 is 200, both go into 16. So 3 and 72 are both factors of 216. Now I'm going to keep counting. Now I'm going to try 4. Yep, so 4 goes in 54 times. So 4 and 54 are both factors of 16. Will 5 work? Nope, because it doesn't end with 5 or 0. So you can write down the 5 and cross it out, or you can just skip over it. So now I'll try 6. So 216 divided by 6, and I get out 36. So 6 and 36 are both factors. Now I'll try 7. Nope, 7 gave me a decimal, so 7 doesn't work. Now I'll try 8. So 8 times 27. Now I'll try 9. Yep, 9 and 24. Oh, I think my page is going to run out here. Shoot. I know 10 doesn't work because it doesn't end in 0. So I'm going to try 11. Nope. I'm going to try 12. 12 and 18. Now I'm going to try 13. Now I'm going to try 14. Now notice when you go 216 divided by 14, you get 15.428. And when you go 216 divided by 15, you get 14.4. So there's that wrapping around point. So 14 goes in about 15 times, 15 goes in about 14 times. So we have counted down, we've started wrapping around with our counting. So that is the full list of factors. Okay? So by doing that instead of that rainbow or smile, you're guaranteed that you'll get your full list. Okay, so 150. So again, 1 and 150. Okay, and now we're going to count. 2 goes into 150 75 times. 3 goes in 50 times. Does 4 go in? Yep. Nope, 4 goes in 37.5 times, so 4 does not go in. Does 5 go in? Yep. 5 goes in 30 times. Does 6 go in? Yep, 6 goes in 25 times. Does 7 go in? I don't think it does. Nope. Does 8 go in? Nope. Does 9 go in? Nope. But 10 goes in 15 times. Does 11 go in? Nope. Does 12 go in? Nope. So notice 12 goes in 12.5 times. So because we've started to wrap around, we can't even get to 13. We know that this is our full list. Okay? So let's just summarize with one more example. So these two questions sound a lot alike. So try not to confuse this. List the factors of 60 and prime factorize 60. Okay, so those are two very different concepts. If I asked you to do the prime factorize of 60, this is where you would either do a factor tree or you would do a stack. Listing the factors of 60, these are all the numbers that divide into 60. So you'd start at 1, and then go to 2, and then go to 3, and count down. So why don't you hit pause here and try doing this question. For the prime factorize, you don't have to know both ways. You only have to do it in the one way that you like. And then also create your full list of 60. And once you think you've got it, hit play and check your answer. Okay, so 1 goes in 60 times. 2 goes in 30 times. 3 goes in 20 times. 4 goes in 15 times. 5 goes in 12 times. 6 goes in 10 times, 7 does not divide in, 8 does not divide in, 9 does not divide in, and when I try 10, I've already looped around. So there is my full list. Those are all the numbers that divide into 60 without leaving a remainder. There's no others. Prime factorizing 60. Okay, so I'm going to go 3 times 20. Remember, with a factor tree, you can start off with any numbers that you want as long as they multiply to give 60. 20, I'm going to go with 4 times 5. and I know 5 is prime, and 4 is 2 times 2. So for the prime factorizing of 60, I have 2 squared times 3 times 5. Now, if you would do a stack, remember, you can't divide by 6, you can't divide by 10. Those are not prime numbers. You can only divide by primes. So since 60 is even, I'm going to divide by 2. So 2 goes in 30 times. 30 is prime, so I'm going to divide by 2 again. Now, 2 does not go into 15, so I need to pick the next prime number, so I can use either 3 or 5, it doesn't matter. So 5 goes in 3 times. So then my answer is 2 times 2 times 5 times 3, which is the same as saying 2 squared times 3 times 5. Okay, now the order to which you write the numbers is irrelevant. I just want to see a 2, a 2, a 3, and a 5 all multiplied. Okay, so this concludes your first lesson. The assignment will be written beside the video on Google Classroom, and I will talk you through how to look, where to look for that and all that. I don't mark assignments. You're doing them for practice. In Math 10C, your entire mark is based off of your quizzes and your tests. So you want to make sure that you're doing the homework, that you're doing the practice, that it's making sense to you, okay, that you don't have any troubles with it. Now, if you do have troubles with it, you're going to contact me and let me know that, and I'm going to help you through it, so that when you do write the quiz, you know that you've got all this stuff straight in your head. Okay, we'll talk again. See you in the next one.